Hello students, and welcome to our lessons on gradients and intercepts. So we want you to be able to find the gradient, which is the slope of a line, and the intercept of a linear graph. Now remember, a graph is that line that we draw on a set of Cartesian planes. Okay, so the gradient now is a numerical value which describes the slope of the graph. Now if I have a look at a positive gradient, what can you see happening? You can, oops, that's not working for me. What if I go to draw? Yeah. A positive one, it's going in which direction? It's starting and going up, isn't it? Whereas a negative is going down. So that kind of makes sense. If you go up a hill, it's a positive gradient. If you go downhill, it's a negative gradient. We can describe gradients using geographical terms as well. So you can say it's a steep or it's a slight incline as well. Now we can find the gradient by comparing the vertical rise with the horizontal run. So if I am having a look now at my different run values, you can see my runs go across. So they are the x values. So if I'm looking here, this has got to be my first x value, this has got to be my second x value. Same way here, it's first x value, second x value. Now it's going to be found by comparing the vertical rise with the horizontal run. So let's have a look at the vertical rise, and you can see that the rise goes up and down. So where are we? Here we go. Just looking at rise over run. So if I'm starting here, this is going to be my first y variable. And this is going to be my second y variable. So we can see that we've got two sets of coordinates. So this point we would actually just say is x1, y1. And this point here is going to be x2, y2. And that's going to be a positive one because you can see that we're going uphill. Now looking at my negative gradient, this is going to be my y1 because we're starting at the top and we're going down, aren't we? So this point here we describe as x1, y1. And then down here is going to be y2. And then if I'm just using points here, there's going to be x2, y2. Okay, now the formula for the gradient in a line segment between 2 points is when we look at two coordinates, so x1, y1 and x2, y2, we just say the gradient, or m, in our linear equation is y2 take y1 over x2 take x1. Now I won't belabor the point today, but if we're having a look at a linear equation, they take the general form y equals mx plus b, and that m term is going to be the gradient in a linear function. Now the x-intercept is where the graph crosses the x-axis, and the y-intercept is where the graph crosses the y-axis. So we're going to pull up our sim again and just have a quick look at that, and just have a look at this line that we've drawn here. In this case, this is going from left to right, so we're going up. So you can see that we've gone up 3 and across 5. So we say our slope is 3 over 5. If I wanted to turn that into a decimal, that's what, 6 over 10 or 0.6. And our rise, so my first set of coordinates is x1, y1, so negative 5, 2. My second set of coordinates is, so this is x2, y2, so x2 is 0, y2 is 5. Now to find my slope, what is it? The slope equals y2 take y1 over x2 take x1. So we've got, let's see, y2, let's see, that's our y2, and 2, that's got to be our y1, hasn't it? So let's look at y1, yeah, so that's the same. Now x2 take x1, so this is our second set of coordinates. x2 is this one, that's good. And negative 5 is that one there, yeah, so that matches up nicely. Now I can change this around, of course, and change the slope of the graph. But that's the point of today's lesson, is just to find, first of all, the slope of the graph. You can also see that this crosses my axis here at +5 and, what's this? Well, that's 9, that's got to be 8. So that's like a half value, I suppose, at 8.5. You won't tell me nicely, no. So let's do this on a bit of paper, so to speak. So for the linear graph, find the rise and the run and calculate the gradient. So what we need to do is find our x and y values. So let's label them. So we're going, this case, from left to right, we're going down. So we know that the gradient is going to be a -1. So what's my, so that's going to be x1, that's going to be y1. L is going to be x2 and y2. And let's find those actual points now. So we've got x variable is 1, 3. And down here, this is going to be, oops, be nice, 6 and 1. Now we just substitute into our formula. So m equals rise over run, which equals y2 take y1 over x2 take x1. And now this is where we substitute in. So my y2 value has got to be my second one, so it's got to be this one here. So it's going to be 1. And now we're going to take away y1, which is 3. 1 take 3. And then my x2 variable is this 6 over 6. And then my x1 variable is 1. So let's do that. 1 take 3 is 2. 6 take 1 is 5. And that's got to be a negative, hasn't it? 1 take 3 is -2. So it's -2 over 5. Now, I can leave that as a fraction, or I could also express that in decimal. So I know that 2 over 5 is the same as saying 4 over 10. So I could also just express this as -0.4 or -4/10. Do we have an intercept there? Well, we do have an intercept here where it crosses the y-axis, don't we? So that's like 3 and a bit there. Let's find one that's more precise. Now, in this graph, let's find the gradient. So, and then we're going to find the x and y intercepts. So, what do we know? That the gradient equals the rise over run, which equals not the x variables, the rise is the y variables. So y2 take y1 over x2 take x1. And let's substitute them in. I'm going to be nice and lazy. If I can do this on the line and get some zero values, it's going to make it easier for me. I could take any term. I'd be looking for points like that, where it just crosses the line of each of these nicely. But because they cross the axes, I'm going to just make it a little bit easier for me and use those intercept points. So what's my x1 and y1? So this has got to be this one up here, isn't it? So x1, y1. So my x variable is 0 and 6. Down here is my x2, y2. And I am looking at 3, 0. So you can see that I've used the intercept values because this one is a 0 and this is a 0. And then let's substitute into our formula and solve. So my y2 value is 0. Oops, nasty screen. So 0. Take y1, which is 6, and then x2, which is 3, take 0. Now 0 take 6 is negative 6. 3 take 0 is 3. So this is going to be a nice easy one, isn't it? 6 divided by 3 is 2. And that's going to be a negative because it's a negative 6 divided by 3. So my gradient equals 2. My x-intercept and my y-intercept. Now we have identified them, haven't we? I can identify them from my set of coordinates. So remember, that's where does the line cross the x-axis? Sorry, the x-axis at here, because this is our 0 on the x-axis. And so what do we say? That our x-intercept is 3. So we're crossing our x-intercept here. And then crossing our y-axis. This is our y-axis at positive 6. Be nice. Okay, now we can just substitute into this formula and do our gradients, which is what we've done anyway, so we might just do this quickly. So just have a look here. We'll use the formula gradient equals y2 take y1 over x2 take x1. Now it's always good when you get your set of coordinates just to label them so you can come back to them. So what do we say? Gradient equals y2 take y1 over x2 take x1. What's my y2? That's the 5. What's my y1? That's the 2. And what's my x2? That's this one over here. That's going to be 9. And my x1 is a 3. Now 5 take 2 is 3. 9 take 3 is 6. 3 over 6 is like saying 1/2. Or you can express it as a decimal, which is 0.5. I see that your book has just got you doing it as a fraction, so that's fine. Okay, when you've done that Year 9, I'd like you to work on your mastery exercises, please.